to math class. Okay, consider the following problem. A rubber ball is dropped from a building that is 20 meters high. Each time the ball bounces, it bounces back up to 80% of its previous height. Calculate to the nearest centimeter the height of the ball after the 15th bounce. So Lucasito decides to solve the problem using a geometric sequence where t of 1 equals 20. Explain why the 15th term would not be the answer to this problem.
Because 20 isn't the first bounce, it's the height of the building.
20 is not the height after the first bounce. Which means t of 15 would not be after the 15th bounce. It would actually be after the 14th bounce. So if I was to use his method, that would be t of n equals a times r to the power of n minus 1. A is the first term, or 20. What is r? 0.8. I don't have to take it away from 100 because it bounces back up to that 80% mark. And then n would be the number of terms, which would have to be 16. I would need 16 terms to get to the 15th bounce. So then I would get 20 times 0.8 to the power of 16 minus 1. And what do I get? So if I was to round this to the nearest centimeter, because this is in meters, what would that be to the nearest centimeter? 70 centimeters. Thank you, Evan. Nicolette argues that the value of T15 should be the solution to the problem. If I'm going to calculate the height after the 15th bounce, I should be looking for the 15th term. So if Nicolette chooses to do this option, explain why the first term would not be 20. Because T of 1 has to be the height after the first bounce, which is not 20. What would the first term then be? What would be the height after the first bounce? 16 meters. So now if I use Nicolette's method, I get T of n equals a times r to the power of n minus 1. Her a is 16. Her r is still going to be the 0.8. But in this case, her n will be 15, the 15th bounce. So I get 16 times 0.8 to the power of 15 minus 1. And what do I get? I get the same answer. So if I was to use a formula or an equation to represent the height after x bounces, for Nicolette, 0.8. And so if she wanted to find the height after 7 bounces, her R value, or the exponent on her R value, would be 7 minus 1. So it would be the number of bounces minus 1. That would be Nicolette's. If I look at Lucasito's, the height for his would be starting at the 20 times 0.8. And then if I look at his, when it was 15 bounces, this value here ended up actually equaling 15. So if I had after 7 bounces, this would end up being to the power of 7. It would be the 8th term, but it would be the 7th bounce, or the exponent would be 7. So question D says, write an equation that could be used to determine the minimum number of bounces required for the rebound height to be less than 2 centimeters. So first of all, if I have 2 centimeters, my formula deals in what units? Nope. What was the formula? Meters. So I have to convert this into meters, which would be 2/100ths of a meter. So the equation that would be used to determine the minimum number of bounces would be my height would equal 0.02. And then I could use either Nicolette's or I could use Lucas's, although his, I don't have to worry about the x minus 1. So 20 times 0.8 to the power of x. So if we use our graphing calculator to do this, so if we're using the calculator to do this question, it would end up being, let y1 be equal to 0.02, and then my y2 be equal to 20 times 0.8 to the power of x. And then I need to do some adjusting on my window settings. So in my window, my x's refer to the number of bounces. Okay? And I know from previously that after the 15th bounce, the height was 70 centimeters. So I know I need to have more than 15 bounces, but I know I don't need negative bounces. So I could go up to 25. My height, what's the height that I'm trying to get or trying to see? It's that 0.02. So I don't need to have a great big height. I could even just start at 0 and go to 2 if I wanted to. And then my scale, I could just leave at 0.5s. If I put a scale at 0, it just draws a line. It doesn't put any tick marks in it. There's my 0.02. And I'm actually not enough. So I need to adjust the window settings again. Go up to maybe 30 this time. And that 2/100ths, I need this to be much smaller. So even if I went to 0.5 and then graphed it, now I can see a separation of the line. It doesn't just look like it's on the axis. Still doesn't look like it's crossing. So try again. Maybe go up to 40 this time. And you know what? I'm going to change this to be 1/10. And now I've got an even bigger gap so that hopefully I can see it actually cross the x-axis. Or sorry, cross the intersection point. So now that I have the intersection, I can use the Calc 5. And I don't actually have to scroll close to the intersection because there's only one intersection point on the screen. If I press enter, it'll go to second curve. If I press enter, then it'll say guess. I don't want it to guess, but it will eventually jump to here. So I get an answer of what? 30.956. Okay, so if we put that on here, I get that x equals 30.956. So what is the minimum number of bounces I need for the height to be less than 2 centimeters? Say it louder. 31 bounces. If this number here had been 30.32, how many bounces would I need? I would still need 31 because at 30 bounces the height isn't quite enough. And I could check that. If I use just the formula and I went 20 times 0.8 to the power of 30, I get 0.0247, which is about 2.5 centimeters. It's only when I put in 31 that it's below 2 centimeters, and that was the condition of the question. Okay? So then the last example. Mike invests $5,000 in a GIC, which is a guaranteed investment certificate. Each year, 3% interest is added to the value of the investment at the beginning of that year. Consider the geometric sequence which represents the value of the investment at the end of the year. So what is my growth factor? Would be the 3%, but then I have to add that on to the 100% that I already have. So I'd have the 100% of the investment plus the 3% interest, which when I convert to a decimal, I get my 1.03. That's my growth factor. B says write a product which represents the value of the investment after 1 year. This product will represent the first term of the geometric sequence. Don't evaluate this product at this time. So at the end of the first year, I would have my $5,000 and I would multiply it by that growth factor. That would be the value of the investment after the first year. What would I do at the end of the second year? How would I find the value of the investment after the second year? Yeah, I would just multiply by 1.03 again. Remember, it says do not evaluate.